Hi guys, this is lesson 111. It is called Solving Problems Involving Permutations. Alright, so let's think about how many different outfits can be made with 2 pairs of pants and 4 sweaters, or 4 shirts, sorry. So we have seen tree diagrams. It's been a while, but you have 1 pair of pants, pant 1, and you have the second pair of pants, which we would call pant 2, excuse me. Alright, so I have shirt 1 that I can pair with this, shirt 2, shirt 3, shirt 4, and then I could do the same thing with pants 2. Shirt 1, shirt 2, shirt 3, and shirt 4. So altogether, how many different options do I have? Well, I would have 8. All right, 1, 2, 3, 4, 5, 6, 7, 8. So 8 total outfits. All right, a faster way we can do this is something called the fundamental counting principle. So if an independent event M can occur in M ways, and another independent event N can occur in N ways, then the number of ways that both events can occur is M times N. So in that example we just looked at, we have 2 pairs of pants and 4 shirts, and if we multiply those together, we get 8 outfits, right? No tree diagram needed. All right, here's another example. A restaurant offers 4 entrees and 5 vegetable dishes. How many meals with 1 entree and 1 vegetable dish are possible? Multiply 4 times 5, and you would get 20. All right, here's another one. A school basketball team uses 3 colors on their uniforms, red, blue, and white. Each uniform has a top and a bottom. Determine the number of possible color combinations the team can have on their uniforms. So we're going to multiply the tops times the bottoms. How many colors can we use on top? 3. How many can we use on bottom? 3. So we have a total of 3 times 3, or 9 combinations. All right, when a group of people or objects are arranged in a certain order, the arrangement is called a permutation. So the unique way 5 different colored blocks can be arranged is a permutation, right? If I have these 5 colors right here, blue, pink, green, yellow, and purple, if I put the blue one first, then I'm not going to use it again, right? And so because this is happening in a unique way, it's called a permutation. All right. So there are n different items, right? So in that block example, we had 5 different blocks. The first item can be selected that many different ways. So I have 5 blocks. So my first item, I can have 5 different colors there, right? But my second item is going to be n minus 1, or 5 minus 1, which is 4 ways, because I only have 4 blocks left, right? My third item would be 4 minus 1, or 3 ways. My fourth item would be 3 minus 1, or 2 different blocks I could put there. And my fifth block would be the last one left, right? 2 minus 1 is 1. So this is called factorial. You know that anytime we use an exclamation point in math, it's going to be super exciting, right? So the way that we write factorial is n with an exclamation point behind it. It's any natural number, and the pattern is this n times n minus 1 thing. 0 factorial is defined to be 1. So if you ever see 0 exclamation point, that's just 1. So here is an example. If I had 5 factorial, then I would just multiply 5 times 4 times 3 times 2 times 1. So if I had 3 factorial, what would that look like? 3 times 2 times 1, which is 6. All right. So the factorial just means you write everything out and then multiply it all together. All right, so there are n factorial ways to position n students in a line. So if I had 7 students, how could I position them in a line? Well, it would be 7 factorial, or 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040 different ways. Make sure you have your calculators handy for this one. All right, so what if we wanted to find n factorial? Well, we would write it out. Or not n factorial, sorry, 9 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, all right, it's a big one, 362,880, right? Multiply those all together. All right, what if we wanted to do this as a fraction? You can multiply them out and then reduce, or you can make your life easier and reduce first. So what does 3 factorial mean? 3 times 2 times 1. What does 7 factorial mean? 7 times 6 times 5 times 4 times 3 times 2 times 1. Can I cancel anything? Sure, I can cancel the 3's, the 2's, and the 1's. So what's left? 1 over 7 times 6 times 5 times 4, which is 1 over 840. All right, with factorials, order doesn't matter. If order does matter, we're going to use permutations. So this would be something like if you had 8 contestants and you were picking first, second, and third place, the order would matter, right? So here we get this really funky looking notation. The number of permutations of n objects taken r at a time is given by this formula. So n is the number of objects, and r is how many at a time. So notice we have a little n in front of the p and the little r, right? And then you know what n factorial is. We just talked about that. The tricky thing is the n minus r factorial in the denominator. So let's look at an example of that. All right, example 3, 8 people are competing in the 100-meter dash. In how many ways can the runners finish first through 8th place? Okay, so this is going to be a permutation because the order does matter, right? Once you come in first place, you can't have someone else come in first place. So it's a permutation of 8 things because there are 8 people running. And we want to know first through 8th place. So is going to be a permutation of 8 things taken 8 at a time. So how does that look? Well, it looks like 8, capital P, 8, and then we're going to have 8 factorial over 8 minus 8 factorial. This is from this equation right here on the previous slide. All right, so what does 8 factorial look like? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then here, PEMDAS, 8 minus 8 is 0. What does 0 factorial look like? Well, that's just 1. So if we simplify that, we get 40,320 different ways that these 8 people can finish. All right, how is that different from B? How many ways can the 8 runners win a medal in the top, which means the top 3 places, right? So how many ways can they come in first, second, or third? So again, the order matters. So this is a permutation of 8 things because we still have 8 runners. But this time it's going to be taken, so we're going to say 3 at a time. Where did the 3 come from? We want to know the top 3 places. So if we filled this one out, we would have 8 things, permutation, and then it's 3 at a time. So we have 8 factorial over 8 minus 3 factorial, which is 8 factorial over 8 minus 3 is 5. So 8 times 7, 6, 5, 4, 3, 2, 1 being multiplied, and 5, 4, 3, 2, 1 being multiplied. We can cancel all of that. So what is 8 times 7 times 6? That would be 336 different ways that those 8 people could come in first, second, or third place. All right, example 4. There are 10 people running for president of the student body government, each identified by a number. If the candidates are introduced randomly at a debate, what is the probability that the first 4 introduced will be candidates 10, 9, 8, and 7 in that order?